Hey everyone, welcome. Glad you're here. Today we're walking through how to get your app live using Otoshek. We'll keep it simple and hands-on so you can follow along and have your app up and running by the end of this session. Perfect. Let's get started. Fire up your screen, grab a coffee, and let's launch this thing together. Before we dive in, let's take a look at the final product, the app you'll have running in your own cloud and saved in your GitHub as a private repo. To see the demo, just click the Test the Live Demo App button. So as soon as we open the homepage, you'll see the Google One Tap pop-up. It's there reducing sign-in friction and making it super easy for users to log in with Google. We'll come back to that in a bit. But first, the app itself is fully customizable. You can swap the logo, update the content, add new pages. All of it's built to adapt fast. And yep, there's even a dark mode toggle, so users can switch between light and dark with a single click. And since we're talking about the look of the app, the styling framework is up to you too. For now, you can go a Tailwind or Bootstrap, whichever fits your style best. All right, so let's talk about what Otoshek actually does and, why it matters. Most of us developers, we start building a product and then realize, all right, we need authentication, billing, emails, all that stuff. And the funny part is, those things look almost identical across SaaS projects, but they still eat up so much time when you build them yourself. Then comes deployment, and that's where things usually get messy. Moving your app from local dev to the cloud, it's time-consuming and full of little surprises. You get database connection errors, build issues, cross-origin headaches, CSRF tokens misbehaving. It's not the fun part, let's just say that. With Otoshek, you skip that entire stage. You start with a production-ready app, already deployed to your cloud, the code sitting right there in your private GitHub repo, and a CI/CD pipeline set up from the start. So from day one, you're working on what actually matters, your product, your features. And every time you push to GitHub, your app updates automatically. Which means when launch day comes, it's literally just another push. All right, cool. So now that the concept's clear, let's dig into the features. First up, authentication. Otoshek bundles 4 ways to sign in right out of the box, all powered by Django Auth under the hood. First, you've got your classic email and password, standard stuff. Then second, there's the sign-in code via email, which is super handy if you're on a shared computer like in a hotel or library. Since you don't have to type or leave a password behind, it completely avoids the browser cache issue. Third, you can use a passkey, a modern and highly secure authentication method. The flow is really smooth, it bypasses passwords entirely. And finally, there's third-party sign-in. In this demo, we're using Google, but Auth supports tons of providers: Facebook, GitHub, Microsoft, Instagram, and more. Let's start with connecting with Google. And yeah, it's that simple. Now we're in the dashboard, and you can see right away there are no active subscriptions yet. Let's log out and try the passkey option. We go to sign in again, then click Sign Up. This time we pick passkey. The system first asks for our email, then sends a short verification code. Once we enter it, we give our passkey a name and click Create. At this page, the browser offers to save the passkey locally, but instead we choose Use a phone, tablet, or security key. A QR code appears, we scan it with the phone, and the passkey is securely created and linked to that device. The platform itself never actually handles or stores a traditional password. There's no password database to steal if a breach ever occurs. Passkeys use cryptographic keys stored securely on your device, your phone, laptop, whatever, and they're often tied to biometrics like Face ID, fingerprint, or even your device PIN. It's a much safer and smoother experience. You just look at your screen or touch the sensor, and you're in. And since we just connected the passkey through our phone, it's now available across devices, so we're not locked to a single machine. All right, now that's set up, let's log out again and take a look at the doing flow. All right, so yeah, we'll start by going to the pricing page. Here you'll see subscription plans already set up for you. They're fully customizable and wired to Stripe in sandbox mode, meaning you can test the whole payment flow without real money. Users can pick a monthly or yearly plan, but before subscribing, they need to authenticate. So, like before, we'll sign in with Google using the one-tap method this time. Now that we're signed in, let's go back to pricing and select the standard monthly plan. That redirects us to Stripe checkout. Since this is sandbox, we can use Stripe's test card numbers, any future expiry date, any 3-digit CVC, and a test name like John Doe. We complete the payment, Stripe confirms the subscription, and we're redirected back to the app where the confirmation appears. Now we're officially subscribed. In the dashboard, you'll see the subscription details and the expiry date. From there, we can manage billing or cancel, which takes us to Stripe Customer Portal, where the user can update card details, download invoices, or cancel a plan. And that's the billing flow. Up until now, we've seen how transactional emails work. For example, when you subscribe by email, the system automatically sends you a password or a temporary code, whether it's for a signing code or a passkey. But there's also a built-in contact form so users can reach you directly. Let me show you. You enter your name, email, and message, then hit send. And that's it. The message is sent. So that wraps up our quick tour of the app. Now let's dive into how you can actually create this project in your own cloud and GitHub repo. To get started, we select Deploy Your SaaS now. You can do that from the menu or directly on the page. I'll click on the page. Here, we're presented with the technology stack we can customize. First, we choose the cloud provider. Right now, we can pick between Google Cloud Platform and Azure. AWS is coming very soon, and depending on when you're watching this, it might already be available. For this demo, we'll go with Azure. Once we choose the cloud, the stack diagram updates. You'll see Azure selected in the bottom right. What's still missing are the code hosting, backend framework, and front-end styling. Notice that no matter what stack you choose, some services are always included. Stripe for payments, Auth for authentication, Mailjet for emails and the contact form, and PostgreSQL for the database. Next, we select the code hosting platform. At the moment, GitHub is available with GitLab and Bitbucket planned for the future. We'll choose GitHub. For the backend, Django is the option today, with more frameworks coming later. And for the front-end styling framework, we can choose between Tailwind CSS and Bootstrap. For this demo, let's go with Tailwind. Finally, the application model. Right now, it's subscription-based, but we'll also be adding an online store option in the future. With all of that selected, our stack diagram is now complete, showing every choice we've made. We're ready to start generating the code. Now we're on the build page. You'll see the same stack diagram as before, but this time we can actually start the build. There's also an option to set the name of the root folder for the project. By default, it's backend, but you can rename it to whatever fits your setup. For this demo, we'll keep it as backend and go ahead and trigger the build. As soon as the build starts, we begin seeing live progress updates, each step appearing as it completes. At the same time, a new section shows up with all the credentials and configuration details we'll need. Since we selected Azure, the first requirement is an Azure Service Principal, and there's a built-in tutorial right here that walks you through creating it. Next, we'll need the Postgres database, which we'll provision through Supabase. Then come the Mailjet API keys for transactional emails, followed by the Google Auth credentials for Google sign-in. Finally, the Stripe API keys for payments. It's best to collect these credentials while the build is running, so you make efficient use of the time. And don't worry about costs. All the infrastructure created here runs on free tiers. You won't be charged unless you later decide to upgrade or scale. All right, so before we start going through the tutorials to gather our credentials, it's a good idea to keep everything organized in one place. Right here, there's a link to a copyable text. It contains all the variable names we'll be collecting. So let's grab that. I'll copy the text, open my text editor, and paste it in. And there we go. You can see all the variable names neatly listed, ready for us to fill in as we move through each tutorial. All right, let's start with the Azure Service Principal tutorial. I'll open it up here so you can see how straightforward it is to follow. We're going to use the Azure Cloud Shell to get our credentials. I'll split the screen, on one side of the tutorial, on the other, the Azure portal. First things first, you'll need an Azure account. Choose the free account option if you don't have one yet. I'm going to create a new account so you can see exactly how the process works from the start. This way, you'll know what to expect if you're signing up for the first time. I'll speed up the video here just so we don't spend too much time waiting for the setup steps to complete. Once you're logged in, click the Cloud Shell button. It's the terminal icon in the top navigation bar of the Azure portal, right next to the search bar. If it's your first time opening Cloud Shell, Azure might ask whether you want to use Bash or PowerShell, like you can see in my example here. Select Bash. Then it may prompt you to create a storage account. Just choose the subscription you want to work with. In our case, there's only one. Accept the defaults and click Apply. Now we're inside the shell. Let's make sure we're indeed using Bash. You'll know you're in the right environment if you see a $sign at the end of the prompt. You can switch to PowerShell if you like, but for this setup, we'll stay in Bash. From here, it's just 4 simple copy and paste commands. First, copy the initial code block. It gives your service principal a human-readable name. Then copy the second block. This one actually creates the service principal and assigns the correct roles. Next, run the block that grants directory permissions for OpenID Connect. And finally, the last block. It displays your credentials. And there we go. You'll now see 4 values: ARM Client ID, ARM Client Secret, ARM Subscription ID, and ARM Tenant ID. Those are the 4 credentials we need from Azure. Let's go ahead and save these values in the file we created earlier with all our variable names. Perfect. Saved and organized. That's it for Azure. Now let's go back to the list of tutorials. The next one is Supabase, where we'll set up our Postgres database. Just like before, we'll open a tutorial and split the screen with Supabase on one side. I'll create a new account so you can follow along from the start. Under the Sign In button, I'll click Sign Up Now. Then I'll enter my email, create a password, and click Sign Up. A new window appears asking me to confirm my account, so I'll just hop over to my email, grab the confirmation link Supabase sent, and click it to verify my address. Back in Supabase, it now asks me to create an organization. I'll give it a name, keep the type set to personal, leave the free plan selected, and click Create Organization. Next, we'll create a project. I'll give the project a name and set a password. You can either type your own or generate one. I'll go ahead and generate a password. It's important to save this password immediately since you won't be able to view it again later in the portal. As you can see, I'm saving it right into the same text file that already contains the Azure credentials. Done. Back in the Supabase portal, I'll pick the region closest to me or to my users for the best performance, then click Create New Project. Now we wait a few moments while Supabase sets everything up. Once the setup is complete and we see the welcome message, we can click the Connect button. A pop-up window opens showing our connection settings. Under the Connection String tab, I'll open the dropdown and select Python. Then I'll scroll down to the Transaction Pooler section and click View Parameters. This is where we find all the connection strings we need, clearly listed and easy to copy. So I'll go ahead and copy them over to my text file. That's it. We now have our database credentials. We can go back to Otoshek and continue with the next tutorial. All right, so the next one is Mailjet, where we'll grab the API keys for transactional emails and the contact form. So once again, let's split the screen. Tutorial on the left, Mailjet portal on the right. I'll fill in the form, name, email, password, and click Create Account. On the next page, we'll pick a plan. We're going with the free plan, nice and simple. And that's it. We're in. Now let's get those API keys. In the sidebar, click API, then API Key Management. You'll see your primary API key there. Click Generate Secret Key. Oh, right. Before that, we need to verify the email address. So I'll just check my email, open the message Mailjet sent, and activate the account. Once we're back in the portal, we'll return to the same section. Click API in the sidebar again, then API Key Management. Now we can finally click Generate Key, and this time we have our keys. The first one is the public key, and the second one is the secret key. Let's copy both of these and save them in our file with the other credentials. Next, we need to verify the sender email. Go to the top right menu, click on your account name, and select Account Settings. In the first section, you'll see Senders and Domains. Click Add a Domain or Sender Address. You'll notice the email you used to sign up is already listed as a sender address. That's perfect. You can keep it that way, or you can add another email if you'd like to use a different sender address. That part's completely up to you. And that's it for Mailjet. Let's head back to Otoshek and move on to the next tutorial. So next up is Google Auth credentials. We'll open the Google Cloud Console on the right and keep the tutorial on the left, just like before. Since I'm already signed in to my Google account, it recognizes me automatically, but I still need to set up and manage Google Cloud. So here I'll choose my country, agree to the terms, and click Continue. In the top left corner, click the 3 horizontal bars to open the sidebar. From there, select APIs and Services, then choose OAuth Consent Screen. Before we can configure anything, we first need to create a project. I'll click Create Project in the top bar. I'll give it a name, no need to set an organization, and click Create. All right, project created. Now I'll click Get Started to configure it. We'll give the app a name, select our default email as the support email, and click Next. For user type, I'll choose External since we want this app to be available to anyone with a Google account. Click Next again. For contact information, I'll use the same email as before. Click Next, agree to the terms, and that's it. The project setup is complete. Next, on the right side, click Create Auth Client. Here, we'll set the application type to Web Application. Give it a name, and then add the authorized JavaScript origins and redirect URIs. These two fields are important. The authorized JavaScript origins define where the authentication requests can come from, basically which domains are allowed to use your Google login. And the redirect URIs tell Google where to send the user back after they sign in. They make sure only trusted sources can handle the login flow and receive user credentials. For now, we'll use the local development URLs listed in the tutorial. They're just placeholders for testing. Later, once the app is deployed, we'll return here and add the production URLs as well. When everything looks good, click Create. A pop-up window appears with our new credentials. What we need from here are the client ID and the client secret. Let's copy both and paste them into our credentials file. And that's it. We now have our Google Auth credentials ready to go. Okay, back to Otoshek. We've reached our final tutorial, the Stripe API keys. I'll open the Stripe portal on the right, just like before. Click Sign In, then select Create Account. I'll choose Sign In with Google. Fill in the name field, pick the country, and click Create Account. That's it. Our account is ready. Stripe may ask for some additional business information, but we can skip that for now. Here's the important part. Make sure to select Go to the Sandbox, not Live account. This ensures we're working in test mode, where we can safely simulate real transactions without using actual money. Once we're inside the portal, we'll close the Setup Guide. Just click Skip again, and now we're in the Stripe dashboard. On the left of the menu, you'll see the name of your Sandbox account, and at the top, it should clearly say Test Mode or Sandbox. Over on the right, you'll find the API Key section. Just click on the secret key. It copies automatically, and we'll go ahead and save it in our credentials file. And that's it. Those are the final credentials we need to deploy with Otoshek. The only credentials we haven't added yet are the ones for the Django super user. I'll fill those in now, but you can also do this later directly inside the Otoshek portal. We're all set, ready to give Otoshek these credentials when prompted. Scrolling down, you'll see that the build job has finished, which means we can now move on to the infrastructure stage. Okay, we're now in the infrastructure setup stage. First, we're asked to connect our GitHub account. This is the account where a private repository will be created for the application. That's where Otoshek will push the generated code. So I'll click Connect, then Connect to GitHub. I'll sign into my GitHub account and authorize Otoshek. Done. The GitHub account is now connected. You'll see the confirmation on screen showing connected as Otoshek Demo, which in my case is the name of my GitHub account. Next, we can name the private repository that will be created. I'll rename mine to Otoshek Demo and click Next. Now we're on the Azure configuration page. You'll notice that the first 4 fields are the same credentials we generated earlier in Azure Cloud Shell. So let's start with those. We'll go to our credentials file, copy the ARM client ID and paste it into the corresponding field. We'll do the same for the ARM client secret, ARM subscription ID, and ARM tenant ID. Next, we'll give a name to the web application. This is the name that will appear in your Azure portal. Then choose the Azure region. It's best to pick the location closest to the region you selected earlier for your PostgreSQL database. Now, let's validate the credentials. The system will check that the credentials have all the required permissions and roles to deploy successfully. Perfect. Validated. We can click Next. Now we're in the database configuration section. We'll copy the database credentials from our file, the ones we got from Supabase, and paste them here. Then click Validate Connection to test authentication, permissions, and compatibility with Django. Everything checks out, so we click Next. Next is the Django superuser configuration. Here I'll create a simple user, give it a password, and click Next. Now we're in the email configuration section. First, we'll fill in the default from email field using the same email address we used to connect with Mailjet. If you added another sender address in the Mailjet portal, you can use that one instead. For the remaining fields, we'll simply copy the Mailjet API keys from our credentials file, paste them in, and click Next. After that comes the Google Auth configuration. Same thing. Copy the client ID and client secret we got from Google Cloud, paste them into the correct fields, and click Next. Finally, we have the Stripe configuration. We'll copy our Stripe secret key, paste it into the field, and click Validate Key. This step checks that the key authenticates successfully and has the right permissions. And that's it. The infrastructure setup is complete. All credentials are validated and ready for deployment. At this point, we reach the payment step, which unlocks the actual deployment process. I'll go ahead and complete the payment, and then we'll continue to the dashboard. All right, so now we're in the Otoshek dashboard. You can see the project details, creation date, and the first 3 completed steps: stack configuration, build stack, and set up infrastructure. The next step is deploy project. During deployment, Otoshek will configure Stripe products and prices, provision Azure resources, create the GitHub repository, set up the OIDC connection, push the generated code to GitHub, run the CI/CD deployment workflow, and finally verify the live website. So let's click View Deployment. Now we're on the deployment page where each step's progress is displayed in real time. We'll click Start Full Deployment. You'll immediately see the first steps begin: Stripe products and prices configuration, and downloading the generated project. Once Stripe finishes successfully, the Azure infrastructure provisioning starts. I'll speed up the video here so we don't just watch progress bars. Now that Azure has finished provisioning, a new window appears showing the URL of our web application along with the URLs we need to add to our Google Auth settings. So I'll copy the first URL in blue, then click Open Google Cloud Console. Inside, I'll select the OAuth client ID we created earlier, paste the first URL into authorized JavaScript origins, copy the second URL from Otoshek, and paste it under Redirect URIs. Then I'll click Save and return to the deployment page. The process continues. Next, we can see Otoshek provisioning the GitHub repository, followed by the OpenID Connect setup for Azure. Once that's complete, the system pushes the generated app to the private GitHub repo, which automatically triggers the CI/CD workflow. I can click the GitHub link to open my repo and confirm the code is there. Back in the deployment page, we can see some environment variables printed out. These are the variables you'll need later for your local development setup. The yellow values need to be replaced with your actual credentials, which we already saved earlier. The blue values represent your deployment-specific Stripe price IDs. You can copy them into a .env how on your machine. Down here, we can see the CI/CD workflow running. If you open your GitHub repository and go to the Actions tab, you'll find the same workflow there and can follow its progress in real time. But for now, let's keep watching it directly here on the deployment page. And the CI/CD workflow has finished successfully. The final step is website verification. It takes a little bit of time for the app to go live, so we'll wait a moment here, and done. The app is now online. We can click the URL shown at the bottom, and there it is, our deployed web app live in our own cloud and stored in our private GitHub repo. Let's run a few quick tests. We'll switch to dark mode, works perfectly. Now let's sign in with Google. The Google One tap shows up on the right as expected, but this time we'll sign in the regular way. All good. Let's test the pricing flow. Choose the standard plan. Use our Stripe test card. Click Pay and Subscribe. Payment successful. The subscription is confirmed. In the dashboard, we can see the plan details and expiration date. From here, we can also manage billing by clicking the Manage Billing and Subscriptions button. This opens the Stripe portal where we can update the subscription, cancel it, or add payment methods. Next, let's test the contact form. Message sent. And I can see it landed in my inbox right away. Finally, let's test the passkey sign-in. We'll sign up with a passkey using a different account this time. Into the code sent by email. Scan the QR code with our phone. And that's it. We're signed in with a passkey. No password required. Sign out. Sign back in. The QR code appears instantly. And we're back in with just our phone. Now let's take a quick look at the Azure portal. I'll open Azure and sign in. It recognizes us automatically. We can see 3 resources: App Service, Resource Group, and App Service Plan. I'll click Resource Groups, and there it is. The resource group Otoshek created for us. Let's open it. Inside the resource group, we can see the app service and its plan. If we click the app service plan, we can see the pricing tier. It's currently F1 free. Clicking on F1 opens the pricing table. F1 is free. B1 adds always on, and higher tiers like Premium V3 are ideal for production level performance. Now let's go back to the resource group. Then select our web app. Here we can see all the environment variables we set earlier during the infrastructure setup. Now back to our deployed website. I'll log out and show you something useful. One of the first things I like to do once the web app is live is connect my Google account to the Django superuser admin, so there's no password to remember. Let's go to the Django admin by adding /admin/login to the URL. We'll sign in using the credentials we created earlier in Otoshek. Once inside, we can see the Stripe integration already configured. The API key is stored in the database. If we go to Users, we'll see 3 accounts. The admin account we created in Otoshek, the Otoshek demo account created via Google Login, and the Otoshek SaaS account created with Passkey. Let's open Otoshek demo. That's our main Google account. We'll give it staff and superuser status, then click Save. Now Otoshek demo has the same privileges as the original admin user. Let's log out. Sign back in with the Google account we just updated, and go back to the admin panel. Since this account now has full privileges, it logs in directly. No password needed. Now let's go back to Users and delete the admin account we created through Otoshek. This way, we'll have only one admin account, linked directly to our Google login. And that's it. We've successfully deployed, tested, and verified every part of the app, from build to infrastructure, deployment, and live functionality, all fully automated through Otoshek. The next step is to set up our local development environment so we can start building on top of it and test the CI/CD pipeline in action.